To solve this system by substitution, the first thing we need to do is choose one equation and solve for one of its variables. So if you look at the top equation, and I'm actually going to label them as 1, 2, and 3 so that it's a little bit easier to keep my thoughts organized. If you look at equation 1, it's already solved for x. So this is kind of a break for us because we don't have to solve anything. So I'm going to say for step 1, we are going to choose equation 1, and it is already solved, so we don't have to do any extra work. Okay, so step 2, we're going to take that expression and we're going to plug it into the x's of both of the other equations. So I have to do like 2 separate steps. So first I'm going to take equation 1 and I'm going to plug it into equation 2, and then I'm going to take equation 1 and plug it into equation 3. So let's do equation 1 into equation 2 first. What I'm going to do is I'm going to take the expression 2y and I'm going to plug it in for x in equation 2. So I'm going to have negative 4, and then instead of x I'm writing 2y plus y minus 2z equals 1. And now I just have to simplify. So I would have negative 8y plus y minus 2z equals 1, and then these are like terms, so I'm going to combine them, and this is as far as I can go. So now I'm going to do the exact same thing with equation 3. So instead of this x right here, I'm putting in 2y. So I'll have 2 times x, which is 2y, plus 2y minus z equals 10, and now we have to simplify. So I'm just going to write down the rest of it. I have some like terms here. 4y plus 2y is 6y. So this is my final answer for this portion of step 2. What I have just done now is created a system of 2 equations. So we started with 3 variables and 3 equations. Now we're down to 2 variables and 2 equations. So I'm going to write down these equations on top of each other like we're used to seeing. And we have to figure out a way to solve for one of our variables. Now you could do substitution or elimination at this point. I'm going to choose to do elimination because it's my preference and I think it's a little bit less work. In order to be able to eliminate one of our variables, I think the easiest thing to do would be to multiply our purple equation by negative 2. That's going to allow us to eliminate the z's. So I'm going to copy down the green equation without changing anything. And then I'm going to take the purple equation and everything is going to get multiplied by negative 2. So now my 2z is positive, which will cancel out with the green negative 2z, and I have equals negative 20. Okay, so what I have left now, the 2z's cancel, which is what I wanted. I have negative 19y equals negative 19, and I'm going to come up here because I'm running out of room. If I divide both sides by negative 19, that gives me my y value, which is positive 1. So that is 1/3 of my final answer. Our final answer is going to be written as what's called an ordered triple. And it's going to be x comma y comma z. So my y value is 1. That goes in the middle. Now I'm going to take this y value and I'm going to plug it back into either one of my, either my purple or my green one, and that's going to give me my z value. I'm going to choose the purple one just because it has fewer negatives. So it would be 6y minus z equals 10. So I have 6 minus z equals 10. I'm going to subtract 6 on both sides. So I have negative z equals 4. And then I'm going to divide both sides by negative 1. So my z value is negative 4. So now I have 2 of my 3 answers. So now our last step is to take our 2 answers that we have and plug them into one of our original equations, meaning the ones that are typed on the paper, and find my x value. The easiest one to plug it into is going to be equation 1 because it's already solved for x. So now I'm going to take my first equation and I'm going to write x equals 2y, but I know that y is 1 and 2 times 1 is 2. So that means my x value is 2. So that right there is called an ordered triple, and that is the final answer for this problem. This system we're going to solve using elimination. And this one has all three of these equations in standard form, so it looks kind of overwhelming. I am going to, again, number my equations, 1, 2, and 3, just to kind of keep things organized. Step 1, it says pair the equations to eliminate y, because the y terms are already additive inverses. Additive inverses just means that they add to 0. So if you look at equations 1 and 2, I'm going to write them out. X minus 3y plus 3z equals negative 4, and 2x plus 3y minus z equals 15. All right, so take a look at the y's. They are already same number, opposite signs. So if I add them together, the y's are going to cancel out. So x plus 2x is 3x. The y's cancel, plus 2z, and then that would equal 11. So I'm going to put a box around this because now I have eliminated one of my variables. Now if I do the same thing with equations 2 and 3, so I'm going to copy them down. And then 4x minus 3y minus z equals 19. So if I do that, I would get 6x, the y's cancel, minus 2z equals 34. So now I have two equations with two variables, just like we did for substitution. So really step 1 is where the difference is. It's whether or not you want to set them up and eliminate the same thing, or if you want to solve one of your equations and plug it into both of the other ones. But now it's pretty much the same thing as before. One thing I want to mention, because it just told you what to do in this example, the reason we chose y is because I could figure out two combinations of equations. So like 1 and 2, if I added those together, the y's canceled, and also 2 and 3, the y's canceled. One thing that I used to really struggle with when I did systems of 3 equations is I would like choose equations 1 and 2 and I would eliminate y, and then I would choose equations 2 and 3 and eliminate z. You have to eliminate the same variable both times. Otherwise, it's not going to get you anywhere. It's just going to be a whole bunch of work and you're going to get stuck and not be able to figure it out. So please make sure that when you are doing elimination that you eliminate the same variable both times. All right, so now I'm going to take my new equations, the purple one and the blue one, and I'm going to set them up together. And then we'll figure out what the best way is to solve these. And it looks to me like we already have an elimination problem set up. So if I add these together without changing anything, my z's are going to cancel. And all I'll have is 9x equals 45, and then divide both sides by 9. So my final answer for x is 5. So I already have one of my 3 answers. So down here, my x value is 5. Now I'm going to take that 5 and I'm going to plug it back into either my purple or blue equation to find z. I'm going to choose to do the purple one just because it has no negatives. So it's 3x, which I know is 5, plus 2z equals 11. So 15 plus 2z equals 11. Subtract 15 from both sides. And I have 2z equals negative 4. And then finally divide by 2 on both sides, so I get that z is negative 2. So now I have my second answer, which is negative 2. All I have to do now is plug both of those back into one of my original equations to find y. So I'm going to choose to plug into equation 2. And the reason I'm choosing equation 2 is because my y coefficient is positive. It really doesn't matter. That's just, it's going to save me. I won't have to divide by a negative when I'm done. Okay, so I have 2x, but I know that x is 5, plus 3y, minus z, and z is negative 2, and then that equals 15. So I'm going to do some simplifying here. I would have 10 plus 3y plus 2 equals 15. I can add the 10 and the 2 together, so that gives me 12 plus 3y equals 15. If I subtract 12 from both sides, I get 3y equals 3. And then I'm going to write this up here because I ran out of room. All I have to do now is divide both sides by 3, and my y coordinate is 1. So final answer is 5, 1, negative 2.